So this is a follow-up video of the design project that we have been developing for the EC496 project. So here's a breakdown of it. It's basically remote sensing modules where you measure different environmental factors or anything basically, and you can integrate the sensors into our framework and would display the data for you. For example, we envision the product to be used by Philips maybe, or by even individuals. Philips would use it in the context of like attaching these sensors to their appliances and showing the benefits of the user in the long run, and maybe telling the user that this product is like no longer energy efficient, so you might want to replace it. There could be other uses for individuals. For example, it would make them more aware of the environmental footprint. For example, lights are on and nobody's in the room. Those kind of patterns would also be detected by our system. So over here what we have is a sensing station. This black box is called a sensing station. It's connected through a battery through a TI board, and now it's transmitting data from this guy. This is a temperature sensor. It's housed in a Lego box just for packaging. However, this is not packaged. This is a motion sensor that we bought off SmartFun, and they're daisy chained over DB9 connectors, over which they're exchanging I2C signals to communicate with each other to basically do address resolution protocol and sampling data. This setup, I would call this to be kitchen, just because I expect this sensor to be placed in the kitchen. This one is a bedroom. This also has the same setup, sensing station, and we have two sensors. We have a temperature here and a light sensor there, again connected through DB9. So these are communicating over wirelessly through a protocol, a TI proprietary protocol called Simplicity, which is good for low power. These all the boards are actually from our TI. So we have entered a TI competition as well. So that's why we're using them, and plus that TI has that benefit there. They consume very less power in nanowatts in the standby mode, so that's why it's useful as well. So here is the base station over here. It's communicating through those guys wirelessly. As you can see, some flickerings here and there. So let's see the user interface. So we have over here, we are in the bedroom over here, and we can see there is a light sensor and temperature sensor attached to it, right? So you can click on the light sensor and you can see the intensity is 100%, and you can see a log of data as well, like as you see in Google Finance. Maybe temperature is a better variation. So here's the temperature, the fluctuations in temperature that have been recorded over the historical graph. This is a historical graph. So you can see the dates when things were sampled, and we're basically storing in a SQLite database, and these are all Google APIs, right? Big thank you to our friend Bijan if he's watching this. He basically gave me the idea of using a Google API. So it's showing the current temperature reading. As you can see, the gauge is changing, so it's varying, right? Even the light sensor, I can make it change at demand. So for example, I'll just cover my hand. Let me get that, and hopefully the temperature, the light gauge will change. It should do it shortly. As you can see, it's going to 86, right? So now that I remove the hand, it should go back to 100 as well. 685, and it should go back 100. So we can see this change right over here. See in the graph, we have this change recorded, and we can also compare graphs. For example, if I get my shift key here, hopefully, let's see. So we can do a real-time comparison of the graphs. So you can see patterns. So you can unlock patterns like the lights are on and nobody's in the room. So that's what it's used for basically. That's where actually the value that we add to this product. We want to do one last thing. You can see the status, they're all on right now, right? So I'll try removing the temperature sensor, and we should see the tick go away. So I'll try to place my camera here. Doesn't work. Anyhow, so over here we will try to disconnect over here the temperature. See, we should see that effect right over here. Here you go. It's across, so we can reconnect it. Let's try. Hopefully the wires don't come out. Let's see. Oh, look at that. It's reconnected. So see, it's doing address resolution protocol on demand, so that's why you are able to attach. Actually, up to 3 sensing frames can be attached to the sensing station. So you can have at most 3 sensors. So we can the applications are huge for this thing. Like you can place them around your house and see where you're wasting energy. And I think there could be other applications as well, like and maybe in hospitals where different sensing sensors could be attached to patients that are in ICUs or something, and it would wirelessly feed in the data to the receptionist. So like I heard of a case that the patient was some fluid was done and there was a beeper that was going on, but nobody was there to respond to it. So those kind of things, I think we can also have some biomedical applications here. So I hope you enjoyed it. I'll wait for your feedbacks. Okay, thanks.